Okay, Honors Algebra 2, we are on now Lesson 6, finding real roots of polynomial equations. This should say real, not read, real. There we go. Okay. Earlier, we factored quadratic equations and then used quadratic factors to solve a quadratic equation. In the last lesson, we learned to factor polynomial equations by grouping and using a graph. Today, we will use those factors to solve a polynomial equation. So example 1, solve the equation by factoring. So the first step is to look, of course, for what it has. First step is to make sure it equals 0 and that the polynomial is written in standard form with decreasing exponential value, which it is. And now you're going to look and see if there's a common monomial that can come out. And in this case, you can see that 4x to the fourth comes out of every factor. So I'm going to take that out, 4x to the fourth, and I'm left with x squared plus x minus 6 equals 0. And now, once you have factored out that common monomial, you look at what's left, and that's a quadratic, which is quite convenient because you know how to factor a quadratic, and you get, you're going to factor that quadratic, x, 3, 2, we would need to have a positive 3 and a negative 2 equals 0. And so now my polynomial is fully factored, and once it's factored, you can find your zeros. So the most common error here is people forget that that gives you a 0. The 4 doesn't, but x to the fourth does. In fact, that gives you the 0, x equals 0. And if you get confused about that, then just go 4x to the fourth equals 0. Solve that. So x to the fourth equals 0 divided by 4, which is 0. And then the fourth root of 0 is 0. And there you are. You have x equals 0 as a 0. Here, we have the 0, x equals a negative 3. And here, we have the 0, x equals 2. So that would be my answer. You can separate it like that, or you could write 0, negative 3, 2. Any one of those is fine. Okay, B. So looking at B, the first thing is to get it in standard form. So obviously it's not because 25 is over there and we need to set it equal to 0. So I'm going to go 2x cubed plus x squared minus 50x minus 25 equals 0. The next thing I'm going to try is that since there are 4 terms, you always want to check about factor by grouping. This is 4 terms. Obviously it can't be factored like a quadratic because that can only be 3 terms. So let's check and see if the grouping works. So it's in standard form. Look at these two. What do those two have in common? They have an x squared in common. And if I took that out, I would have 2x plus 1. Don't forget, when you take x squared out of this term right here, you have a 1 left. These two terms, they have a 25 in common. And 2x, so it's looking pretty promising. I know if I take a 25 out there, I need a 1, and it needs to be exactly the same, so I need to make that a plus 1, which means I have to take out a negative 25. All right, so now I went from, these are 4 terms here, right? 4, well, when I rewrote it, it was 4 terms. 4 terms. And now I have 2 terms. This right here is a 2-term expression. I forget, equals 0. So here's one term, here's the other term. Both of those terms have a 2x plus 1 in common. I'm going to take that out, 2x plus 1. What am I left with? Well, when I take it out of this term, I have an x squared left. When I take it out of this term, I have a minus 25. So I'm here. But I'm still not done because I see x squared minus 25, and that is the difference of squares. So my final answer will be 2x plus 1. X minus 5, x plus 5 equals 0. And that would be the factored form of this polynomial. But the question here is to solve it, not just to factor it. So the solutions then are the x values, or the zeros. So therefore, my x equals, right here I get the answer of -1/2. Here I get the answer of 5. And here I get the answer of -5. So there's my solution to my polynomial. Okay. So sometimes a polynomial has a zero that occurs more than once. And we kind of mentioned this in the last lesson. Which zero occurred more than once in example 1? So if you look at that, this zero, x equals a -3, that's 1, degree 1. This x equals 2, that occurred once. But over here, this x equals 0, how many times did that occur? 4 times. So x equals 0 occurred more than once. Why? Because x is to the 4th power. So x equals 0 occurs 4 times. So if you want to be technical about example 1a, the answer would be x equals 0, 0, 0, 0, -3, 2. But that brings us to this word called multiplicity. The real zeros of a polynomial correspond to the x-intercepts of the graph of that polynomial. Right? I mean, you know that. I know sometimes the math language gets confusing, but if I have a graph, you know, I don't know, here, the real zeros of the polynomial, 1, 2, 3, correspond to the x-intercepts, 1, 2, 3, of the graph of the polynomial. So we can find information about the number of real zeros of a polynomial by looking at the graph. And conversely, we can tell how many times the graph is going to touch or cross the x-axis by looking at the zeros, or at the factored form of the polynomial. So a zero has a multiplicity, which refers to the number of times, here's your definition, the number of times that its associated factor appears in the polynomial. For instance, the quadratic x plus 3, x minus 2 has the zeros x minus 3 and x equals 2, each occurring 1 time. The 11th degree polynomial, x plus 3 to the 4th, x minus 2 to the 7th, that's an 11th degree polynomial, has the same zeros as right here. The zeros didn't change. But in this case, the x minus 3 has multiplicity 4 because of that 4. And the x plus 3 occurs 4 times. That is, the factor is raised to the 4th power. And the x equals 2 solution has a multiplicity of 7 because of the factor x minus 2 occurs 7 times. So remember, if you have this right here or something similar to that, what you technically have is x plus 3 times x plus 3 times x plus 3 times x plus 3. You have 4 of those x plus 3s. And then what do you have for the other? You have 7 of these. That's kind of fun. One, 2, 3, 4, 5, 6, 7. And so that is multiplicity. How many times does it occur? Up here in this one, when we had 4x to the 4th, we really had, 4x, x, x, x. There are 4 x's. That's what that means. Therefore, we had x equals 0 4 times, multiplicity of 4. Okay, so example 2, list each zero and its multiplicity, then graph each on your calculator. What do you notice? So for this first one, A, the zeros we get here, this is a 0, which gives me x equals 0. It has no exponent, so it has a multiplicity of 1. This is a 0. So x equals 3, but it has a multiplicity of 2. And when you graph it, here's 0, here's 3, you are going to get this graph. And this is a 0, of course, regular 0. The graph goes straight through. and it had a multiplicity of 1. This, though, had an even multiplicity. And notice how the graph touches it but bounces. Okay, let's do another one. My zeros are x equals -1. That's a multiplicity of 1 right there. This one gives me x equals 2. That has a multiplicity of 2. This one is x equals 4. That gives me a multiplicity of 3 because of that exponent. So the exponent tells you the multiplicity. So when you graph that, we have -1 right here, 2 here, 4 here. Those are my zeros. And you graph that, you're going to come down, you're going to go up, you're going to bounce, and then you're going to go up. But wait, I want to fix this a little bit right there. Go away. Okay, because when you have a multiplicity of 1, you go straight through the point. When you have an even multiplicity, you're going to bounce. And then when you have an odd multiplicity greater than 1, when you go through, you're going to do a jag. So this is straight through because it's a 1 multiplicity. This is a 3 multiplicity at 4, and so you do a jag. And at an even multiplicity, you bounce. So let's write that out. Odd multiplicity, the graph crosses x-axes. It actually crosses it. Like here, when the multiplicity was 1, when x equals 0, we went straight through. For any odd multiplicity, you're going to go through the graph. So you're going to change from -y to +y, or +y to -y. You go through the point. And if the multiplicity is greater than 1, it will bend or jag a bit. Okay, even multiplicity, the graph touches the x-axis at that point, but it doesn't cross. It bounces. So an even multiplicity will bounce, an odd multiplicity will cross. And if it's an odd multiplicity greater than 1, it will cross with a bit of a jag in it. And there you go. You need to know that, because you are going to be able to graph these polynomials based on the multiplicity. All right, example 3. Using a graph to help you get started, identify the real roots of each equation, state the multiplicity of each root, verify all roots algebraically. So when it says using a graph to help you get started, that means you are going to put this polynomial equation into your graphing calculator and hit graph. And you're going to get a graph. And you're going to look at that graph and you're going to find one of the zeros. But you can't just say that is a 0. You're going to use synthetic division to verify those zeros. All right, so let's see. Do I have? Yeah, I do. Let me pull up my graphing calculator here real quick. I should have done this before. No, we're doing the freebie next. All right. Okay. So let's put this in here. We have, it's so small I can hardly read it. X. I don't know. What am I doing? I want to go to Y1. All right. We want x raised to the 4 plus 8x. Oh my. It's been a long Christmas break. Move our cursor. Okay. Plus 8x raised to the 3. Move my cursor. Plus 18x squared minus 27. That's my function. Make sure I have everything in there right. I think I do. So now I want to graph it. All right, So you should be able to get that on your calculator. And then, I wonder if I can move that over. Look at that. So impressed. Okay, probably going to disappear as soon as I write though. But when I look at that graph, I can see a couple zeros, or what looks like a zero. For example, I don't know if I can even write on this. Nope, doesn't work. All right, so it looks like x equals 1 is a zero. And it looks like x equals 1, 2, 3, or negative 3 is also a 0. Now look at how my graph jags there. That's what I'm talking about. Here, it crosses straight across. So it looks like when x equals 1, I'd have a multiplicity of 1. But it looks like when x goes equal to negative 3, I have an odd multiplicity greater than 1. So I have that in my mind, and I'm going to come over here now, and I need to verify those. So as soon as I start writing, my graph's going to disappear. So I had x equals 1, and I had x equals a negative 3. That's what it looked like on my graph. But now I need to verify all roots. I identified them looking at the graph, but now I need to verify them. Oh, I need to state the multiplicity. It looks from the graph that x equals 1 has a multiplicity of 1. And x equals negative 3 would have a multiplicity of a negative number. But I know that the degree of my polynomial is 4. So I can only have 4 roots. That's the most I can have. So if I have 1 at 1, then I can only have 3 at negative 3. And look at that, that together makes 4. Yay. Okay, so I'm going to verify my roots. So to verify it, I'm going to set up my synthetic division. And I go 1, 8, 18. Don't forget to put a place marker in for x to the first power, and then I have negative 27. Let's start with 1. So I bring my 1 down, multiply, add, and I have 9. Multiply, add, and I have 27. Multiply, add, I have 27. Multiply, and I have 0. And I have verified that x equal to 1 is a root, and x minus 1 is a factor. That's what that 0 means. All right, so now I need to do it again with negative 3. So this is the, and remember here when I started, I had x to the 4th, right? This was x to the 4th. But now I have taken out a factor. I've taken an x out. So this is now an x cubed. If I had to write this out, I would say 1x cubed plus 9x squared plus 27x plus 27. But I'm going to factor it again, so I'm just going to drag down my synthetic division again and put a negative 3 because that was one of my zeros. So I go 1, negative 3, which gives me a 6, gives me a negative 18, which gives me a 9, and a negative 27, and there I got another 0. Yay! So what does that tell me? It says that x equals negative 3 is a root, or a 0, and x plus 3 is a factor. But I said I had a multiplicity of 3 for negative 3, so I do it again. Now this was x to the 4th, this was x cubed, this is an x squared, so I know I'm at a quadratic here. If I wanted, I could just stop and factor that. But I'm just going to go along because I think this is so easy. Negative 3, 3, negative 9, 0. There I am again. X equals negative 3 is a root. X plus 3 is a factor. Right here, this was x to the 4th. This was x cubed. This is x squared. This is x to the first power. So this means I have x plus 3, which is my last one. This tells me that x equals negative 3 is a root, and x plus 3 is a factor. So I have verified that the zeros, or the solutions, the zeros, whatever you want to say, of my polynomial are x equals 1, multiplicity of 1, right there, and x equals negative 3, multiplicity of 3, because of these 3 right there. And that's exactly what I saw looking at the graph. But looking at the graph is not enough. You have to verify it. So when it says verify your roots, that's what you're going to do. If it said to write it in factored form, write polynomial in factored form, then you would write this polynomial is x minus 1 times x plus 3 cubed. There it is in factored form. Okay? Next problem. I think I need a little more space. Get rid of some of this. Okay. Let's get a new color. How about fluorescent green? Okay. So we have the equation x to the fourth minus 21x squared plus 80. So again, you can graph that. Let me pull up my little grapher. Move it over to the other side. All right. And we're going to go to y1. We want to clear that. All right. So I have x raised to the 4. Nope, it didn't raise it. Interesting. Delete. Raised to the 4 minus 21x raised to the 2 plus 80. Graph. Oh my, lots of zeros. So looking at that graph, it looks like the negative 4 is a 0, and it looks like it's a multiplicity of 1. It looks like it goes straight through. And then over here, 1, 2, 3, 4 is also 1, so I have negative 4 and positive 4. And the other two zeros look like they're fractions, so I don't really want to mess with those. So I'm going to go with negative 4, positive 4. I'm going to go with they both look like they're multiplicity of 1. Now I say look like because if I zoomed in more, there could be a tiny zag. But for my purposes here, I don't need to worry about that. I just need to have the graph. What it does for me is it gives me a starting place to factor my polynomial. So I'm going to say x equals 4 and negative 4 look like multiplicity of 1. Which means, of course, if those are each multiplicity of 1, right there I know there's only 4 roots, and there are 2 more roots, and so those are those 2 that look like decimals. So now what I'm going to do is set up my synthetic division. I have 1, a 0 for x cubed, negative 21 for x squared, a 0 for x to the first, and an 80 for my constant. And I'll put 4 there. 1, 4, 4, 16, negative 5, negative 20, negative 20, negative 80, 0. Yay! That means x minus 4 is a factor. And x equals 4 is a root. Do it again with negative 4. So 1, negative 4, 0, 0, negative 5, positive 20, and there it is. So x plus 4 is a factor. X equals a negative 4 is a root. So in this case, though, those other two zeros, remember this was the quartic right here. This is x to the fourth. I took out one x and I had an x cubed. These numbers here would give me a cubic. These numbers here will give me a quadratic. And I can solve a quadratic in many different ways. I know that the solution to this quadratic will be decimals or maybe a irrational number or something. So I'm going to set that up. I have x squared plus 0x minus 5, and that would be the factor right there, x squared minus 5. But that gives me two answers. So at this point right here, I have the quadratic I have the polynomial x minus 4 times x plus 4 times x squared minus 5. And I have the roots, x equals 4, x equals negative 4, and then I have this. Well, I need to find those two zeros. So how do I do that? I'm going to set that equal to 0. And I'm going to solve it. So x equals plus or minus the square root of 5. And if you remember that graph, there it is. These two decimal roots are the positive and the negative square root of 5. So I can write my zeros as 4, negative 4, plus or minus the square root of 5, all multiplicity of 1. There's the solutions. If I ask for the factored form, then I would use this. This is the factored form of the polynomial. All right, so be careful with what you're being asked for. In this problem, you are asked for the roots, but sometimes you'll be asked for the factored form, okay? Notice when I do the factored form, I do that quadratic. This quadratic right here, x squared minus 5, this is called an I'm sure I'm writing that wrong, irreducible quadratic. It doesn't factor. So when I write it, I write the irreducible quadratic of it. Even though that quadratic can give me two solutions, that quadratic does not factor. So that's called an irreducible quadratic. Okay, moving on. Rational roots zeros theorem. Let f of x be a polynomial function with integer coefficients. The only possible rational roots of f of x are p over q, where p is a factor of the constant term and q is a factor of the leading coefficients. So this is called the rational root theorem. And the only possible rational roots. Now remember what a rational number is. A rational number is a fraction. It's the fancy word for fraction. Okay? So if you have a polynomial function with integer coefficients, then the only possible rational roots are p over q, where p is the factor of the constants, the constant term, and q is a factor of the leading coefficients. So this, to be honest, is not nearly as important now because of your graphing calculators, but when I was a student, this was huge. So first thing we want to do is we want to find, well, what are p and q? So here's my function, right here. It has to have integer coefficients, which it does. Remember, integers are just your nice little whole numbers. They can be positive or negative, integer coefficients. Okay, now all the possible roots or zeros of this function are shown by p over q, where p is the factors of the constant. So here's my constant. The constant is the one without the variable. What are the factors of negative 6? Well, the factors of negative 6, factors of constant. And q is the factors of leading coefficient. All right, so my factors for negative 6, well, 1 goes into there, plus or minus 1. 2 goes into 6, plus or minus 2. 3 goes into 6, plus or minus 3, and of course 6 goes into 6. So those are all my factors of my constant. In the denominator, I have the factors of my leading coefficient, which is 5. What goes into 5? Plus or minus 1, plus or minus 5. So now I can put those together. That means every one of these numerators can go over every one of these denominators. So what does that mean? I can have 1 over 1. Which is 1. I can have 1 over 5, which is plus or minus 1/5. I can have 2 over 1, which is plus or minus 2. Or I could have 2 over 5, which is plus or minus 2 over 5. I can have 3 over 1, which is plus or minus 3. And I can have 3 over 5, which is plus or minus 3 over 5. I can have 6 over 1, which is plus or minus 6. And I can have 6 over 5, which is plus or minus 6 over 5. These are the only possible rational roots of this function. So how this helps is if you didn't have a graphing calculator, you could say, okay, well, I'm going to try my synthetic division. These are the numbers I'm going to try. Like I would try the whole numbers first, and then I would start doing the fractions to try to find the roots. Now you have graphing calculators, but you still are expected to know this theorem, and you're going to have to use it a little bit. So just be aware, these are the only possible rational roots of that 0. That does not mean there's not irrational roots. And remember, irrational roots are radicals that can't be simplified. For example, the square root of 5. Or, yeah, we'll just leave it like that. Or, well, I'll just say it, a decimal that does not repeat, for example, pi or the natural number. Okay, number 5. List all possible rational roots of this function. Then find all roots of the function and verify. Okay, so first I need to list all possible rational roots. When you're told to do that, then you have to go with your P over Q thing. And remember, P is the constant. What are the factors of the constant? Well, 1 goes into there and 2 goes into there. That's my numerator. And then Q are the factors of the leading coefficient, which is just plus or minus 1. So now you clean that up, and you have 1 over 1, which is 1. And you have 2 over 1, which is 2. So look, at this time, it's really quite convenient. You only have 4 possible rational roots. Well, you can check those, can't you? So what we're going to do is we are not using our calculator here. We're just going to set up synthetic division. We have 1, -6, 9, -2. And let's start trying these numbers. So, you know, you would try 1 first. 1, 1, -5, -5, 4, 4, and you get a positive 2. No, you didn't get a 0. So therefore 1 is not a root. Then you do it again. 1, -6, 9, -2. Try -1. 1, -1, -7, 7, 16, -16, -18. No. So -1 is also not a root. So we've ruled those out. So now we'll try 2. 1, -6, 9, -2. Stick a 2 in there. -8, 1, 2. Oh, yay, happy day. We found a root. Positive 2 is a root. And then, let's see. When I do that, I'm left, right? This was a cubic. So now I took out my one factor, and I'm left with a quadratic, which gives me this, x squared minus 4x plus 1. And that will not factor, which means that it will not be a rational root, but it still gives me 2 roots. So I need to find those because this problem says find all roots. So what root do I get here? Let's just complete the square and see. So I'm going to say x squared minus 4x plus, take your b number, divide by 2 and square it. So plus 4 equals -1 plus 4. I moved my 1 over and I add 4. So this is x minus 2 squared equals 3. So x minus 2 equals the positive or negative square root of 3. So x equals 2 plus or minus the square root of 3. Therefore, what are all my roots? Well, this is the only rational root. So I have x equals 2. And then I have x equals 2 plus or minus the square root of 3. How many roots did I find? 3 roots. 1 and then 2 here. And that's how many I should have because of that exponent. Number 6. Identify the real roots of the equation. So this time I'm not told to list all possible roots. But I do need to find the real roots of the equation. I need to state the multiplicities. And then I need to verify all my roots. So let's just use the P over Q real quick to get an idea. So the factors of P are 24. So what do I have? 1, 2 goes into 24, 3 goes into 24, 4 goes into 24, 6 goes into 24, 8 goes into 24, 12, and 24. Tons of options. Q, the leading coefficient, is 6. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. There are a lot of options there. So pull out your graphing calculator and put that in, and you're going to see that -4 is a possible root. So I'm going to start with that. We have 6, 7, -73, -14, 24. I'm going to put -4 in there. 6, -24. Add those, -17. Multiply and you get 68. Add those and you get -5. Multiply and you get 20. Add those, you get 6. Multiply and you get -24. There's 1. That tells me that x equals -4 is a root. And it also tells me that x plus 4 is a factor. Here I was dealing with a quartic, right? I took a factor out, And now I have a cubic. And I'm not great at factoring cubics, and so I'm going to find another root. Notice -4 is in the list over here. Where would -4 be? It could be 24 divided by 6 would give us our -4. All right, looking at my graphing calculator, though, I find another one, 3. So now I'm going to do it again. I have 18, 1, 3, -2, -6, and there is another 0. Yay. So that means x equals 3 is a root, and x minus 3 is a factor. Now, notice the directions here. It said find the real roots. So I'm not looking for imaginary roots here. I'm only looking for real. But I have found 2 of the roots. I know there has to be 4 roots, so there could be 2 more, and this is a quadratic. This is 6x squared plus x minus 2. All right, so now I need to solve that quadratic to find my last 2 roots, and I think it factors as 3x plus 2 and 2x minus 1. So that factors, and that gives me 2 more rational roots, which would be -2/3, and the other one would be +1/2. And those also would come from here. So now I can list all my real roots. I have, what do I have? I have -4. I have 3. I have -2/3, and I have 1/2. Those are the real roots right there. All 4 of those roots are rational roots. All of them would have been found from here. Let me just do one more thing though. If I said write it in factored form, you would say that we have x plus 4, x minus 3, 3x plus 2, and 2x minus 1 equals 0. That is the factored form of the polynomial. Those last 2 come from these last numbers right here. I write it as a quadratic and I factor it. That's the factored form. These are the real roots. Real roots. So make sure you read your question carefully and give me what I'm asking for. Example 7. Most airlines have rules concerning the size of checked baggage. The rules for budget airlines are such that the dimensions of the largest bag cannot exceed 45 by 55 by 62. A designer is drawing plans for a piece of luggage that athletes can use to carry their equipment. It will have a volume of 76,725 cubic inches. The length is 10 inches greater than the width, and the length and the depth is 14 inches less than the width. So I am going to, from this last sentence, I'm going to say, okay, well, the width is going to be my x. My length is going to be 10 more than my width, which is x plus 10. And the depth is going to be 14 less than my width, so x minus 14. So those are going to be my dimensions right there. And I do that so that all my dimensions are in terms of one variable, x. Write an equation in factored form to model the value. So the volume is length times width times height or depth. So you're going to say x times x plus 10 times x minus 14. That's my volume, right? Volume equals length, width, and height, which in this case is depth. Interesting. Doesn't write there. Oh well. And so all this, though, we are told equals the volume. And what's the volume? 76,725. And there is a formula or a equation in factored form to model the volume of the piece of luggage. B, write an equation in standard form. So this is factored form. Standard form just means I have to FOIL and multiply all that out. So that means I have 76,725 equals x times x plus 10 times x minus 14. And so I start FOILing. And I have x squared plus 10x times x minus 14. And 76,000, oh my, hold on. 725. So I FOIL that out and I will have oh, I didn't write it down. X cubed minus 14x squared plus 10x squared minus 140x. And as I combine like terms, and remember, if it's in standard form, then you need to have 0 on one side of your equation. So you're going to say x cubed. These two make a negative 4x squared minus 140x minus 76,725. There it is in standard form. Make sure when you do standard form, you have decreasing exponential powers and equal to 0.
Remember to do that, you guys. Standard form.
That's my husband joining in. Okay, C. Think about possible roots of the equation. Could a root be a multiple of 4? Right there. Could root be a possible of 4? So what am I referring to when I say think about possible roots of the equation? Well, we are talking about P over Q here. Okay, what are all the possible P's? It's all the factors of 76,725. This number ends in a 5. Therefore, you know that you have to have like 5 going into there, right? 4 won't go into that number. It doesn't end in an even number. So could it be a multiple of 4? No. Could it be a multiple of 5? Yes. Could it be a multiple of 10? No, because no factor of this number will be divisible by 10. All right, so you can narrow. This is where the benefit of P over Q is. Remember, the numerator is all the factors of this. The denominator is all the factors of your leading coefficient, which is 1. Okay, D. What are the dimensions of this piece of luggage? Well, let's take our standard form, which is right here, and we have our coefficients. 1, negative 4, negative 140, 76,725. Those are our numbers. Stick that in your graphing calculator. And when you do that, maybe we should just do that. Let's put it in our graphing calculator. I know you want the video to be done, but we'll just get this done real quick. We're here. We want to clear. Okay. And so we are going to say we have x cubed minus 4x squared minus 140x minus 76,725. All right. Now, obviously, error. Oh, no. What did we do wrong? You guys probably already saw it. Oh. Oh, my goodness. I would yell at you guys for not telling me I did that, except for you weren't here. I can't blame anyone but myself. Okay. Let's do that again. Minus 4x squared. Minus, oh, how am I doing that? Delete. Go back up there. Oh my goodness. I'm losing my mind. This tells you that the video should be done right now. Go over, go over, go over, go over, go over, go over. One more. Okay. Minus 140x minus 76,725. All right, I think it looks good now. Graph it. Look at there. You can't see anything because you need to change your window. So when I did this, my window, it works at negative 50. Nope. Negative 50. X max is positive 50. Y minimum is, I had negative 80. and y max is 50. What I'm looking for here is a 0, right? So now I graph it. Oh, look at there. I saw a 0 way over there. So you do your little search. You guys know how to find that 0. And when you do that, you find your 0 at x equals 45. That should be at about 45. So I am going to do synthetic division here with 45. 45, and I get 41, multiply 18, 45, add, and I have 1705, multiply, and I get, oh, this is a negative number, by the way, 76, 725, and there's 0. Yay! So that means x equals 45 is a 0. X minus 45 is a factor, although that's not really that relevant right now, because the question is, what are the dimensions? So go back up here. Remember, we assigned all our variables. We said the width is x. So therefore, the width is 45. The length, and we're in inches here. Okay, the length is 45 plus 10. So the length is 55 inches. And then we said our depth is x minus 14. So our depth is going to be 31 inches. And there's our dimensions. And there you go.